Now, in a game, there must be players, right? So that's obvious. There are two players we are going to look at. So we will just be looking at the very simple game. So there are players, and we have the action of each player. And so the action of each player is what they can do. So in the case of this prisoner's dilemma, they can either choose to confess or not to confess. And then behind every action, there exists a payoff and an outcome. So just to give you a brief summary of what this prisoner's dilemma is about, suppose two people committed a crime and that they have been arrested. Now, they are going to be interviewed in two separate rooms, and so the interrogation takes place separately, and that there is no communication between the two people who committed the crime. And so when the police is interrogating them, the police is offering them two options: either that you confess or you do not confess. And so this payoff is outlined in here. So if neither of them do not confess, then the police may not have strong evidence against the crime that they have committed, so each one gets 5 years of sentence. Now, on the other hand, if one player confesses and the other player does not confess, so in this case, the way how we would read this is that the first entry represents the payoff of player 1, and the second entry represents the payoff of player 2. So in the case of player 1 confessing, then he gets 2 years of sentence. On the other hand, if player 2 does not confess, then player 2 gets 20 years of sentence. So again, this game is played simultaneously, meaning that they will choose an action simultaneously. So if both players confess, then each of them will get 15 years in prison, and so on and so forth. So this is how we would read this payoff matrix. Okay. So again, I wrote a note here that says player 1 has payoff represented by the first entry, and player 2 has payoff represented by the second entry. We also assume that there exists full information. So this means that payoffs of each players are known amongst each other. Okay, so first, we are going to be looking at the choice of player 1. Now, player 1, so let's do it slowly so we can have a better understanding as to how we should go about analyzing this game theory. So when player 1 makes decision, player 1 considers all the possible types of actions of player 2. Suppose player 2 chooses to not confess. Then player 1 is left with a choice of not confessing or confessing. So which outcome is better for player 1? Well, player 1 is going to confess, because confessing gives a less severe penalty. But player 1 also considers the case, what if player 2 confesses? So if player 2 confesses, then player 1 can either choose not to confess, in which case he will get 20 years of prison, or player 1 will choose to confess, in which case he gets 15 years of prison. And so player 1 will opt for the lower sentence, so he chooses to confess. On the other hand, now let's take a look at player 2's decision. So player 1 can choose to not confess. So player 2 thinks about it. Okay, so if player 1 chooses not to confess, my options are either to not confess or to confess. Recall that the second entry represents player 2's entry. And so player 2 is going to decide to confess because confessing gives a lighter sentence. And player 2 also considers the case, what if player 1 chooses to confess? So if player 1 chooses to confess, then player 2 can either choose not to confess or to confess. And so comparing the two options, player 2 will choose to confess. Okay, so I wrote down the simultaneous choices here in the notes. So this helps you build a step-by-step structure as to how you should go about determining what the final outcome is between the two players. Okay, so here we see that the outcome is going to be to confess and to confess. Okay, so the reason is because we see two lines. Okay, and we will call this as the Nash equilibrium, which we will define later. But before that, I would also want to define what a dominant strategy is. So let's read this together. So the dominant strategy is regardless of the choice of the other player, if you always choose a particular action, that is your dominant strategy. So let's go back to this case. Now, does player 1 have a dominant strategy? In this case, regardless of whether player 2 chooses to not confess or player 2 chooses to confess, player 1 will always choose confess, right? So this gives a lighter sentence. And so we say player 1 has a dominant strategy. On the other hand, we also observe that player 2 has a dominant strategy as well. So player 2, between choosing not confessing or confessing, player 2 always chooses to confess because confessing gives a lower, lighter sentence regardless of what player 1 chooses. So let's write the dominant strategy between the two players. So player 1 always chooses confess regardless whether player 2 chooses confess or not. And so we call this thus confess. So this is the action. So confess is the dominant strategy. On the other hand, we also observe that player 2 will also always chooses confess, regardless of whether player 1 chooses confess or not. Thus, confess is the dominant strategy. Okay, so the Nash equilibrium is an equilibrium in which each player in a game chooses the action that maximizes its payoff, ignoring the payoff of the other player. So essentially the way how we would determine the Nash equilibrium is when no other player has an incentive to deviate or to change its mind, and we see that in this payoff matrix, the action of confessing and confessing is the Nash equilibrium. So the choice of action is the Nash equilibrium. So Nash equilibrium is confess and confess. Again, the first confess refers to the action of player 1, and the second confess refers to the action of player 2. Now the Nash equilibrium, from here on I will use NE. The payoff is -15 and -15.